Hi, welcome to CIE Math Solutions. In this video, we will discuss basic concepts in probability, specifically experiments, sample space, and events. Welcome to another video of CIE Math Solutions. In this video, we will discuss the basic terms, symbols, and notations about experiment, sample space, and events. We will also discuss common experiments presented in different ways and with varying difficulty. Starting off with the terms, symbols, and notations. The first question is, what is an experiment in probability? An experiment or trial is a procedure or activity that can be repeated infinitely and has a well-defined set of possible outcomes. The other way of saying it is that an experiment is an activity that has random outcomes every time. Examples of experiments are tossing a coin. We know that when we toss a coin, there are two possible outcomes. It can be a head or it can be a tail. Another example is throwing a die. We know that it could be 1 or 2 or 3 or 4 or 5 or 6, but we don't know which one will come out every time we throw a die. Another example is spinning a spinner. Using the colors, there are various colors on the spinner. We know that one of them may come out whenever you spin a spinner, but we don't know which. So these activities denotes an experiment. But what do we call the list of all possible outcomes if you list them down? We call these possible outcomes as sample space. A sample space is the set of all possible outcomes in an experiment or trial. It is denoted by capital letter S. For example, in tossing a coin, there are two possible outcomes. The S or the sample space will contain the head or the tail. There are no more possible outcomes. It's only the head or the tail. This then is our sample space in tossing a coin. The sample space contains head and tail. Next example is throwing a die. If we throw a die and list down all possible outcomes, our sample space then will contain 1 or 2 or 3 or 4 or 5 or 6. Beyond that, no more entries. There are only 6 possible outcomes when you throw a single die. This is what you call as a sample space. But what if we only want a specific set of outcomes? We call this as event. An event is a set of outcomes in an experiment or trial. It is usually denoted by a capital letter such as A, B, C, and so on. So for example, in throwing a die, we know that the sample space contains 1, 2, 3, 4, 5, 6. If, for example, we want only the event of getting an even number, we are only interested of getting an even number, then this event denoted by A will only contain 2, 4, and 6. The same case that if we are only interested on getting an odd number, this event B will then contain 1, 3, 5. Now what if we are interested of getting a number less than 10? This is denoted by event C. Event C then will contain 1, 2, 3, 4, 5, and 6. Take note that the event may not necessarily contain less elements than the sample space. It could also contain exactly the same as the sample space. In other words, the number of elements in an event may have lesser or equal number than the number of elements of the sample space. Let us summarize experiment, event, and sample space using one of the examples. If you throw a die, this activity of throwing a die is what we call an experiment. If we list down all the possible outcomes, those are 1, 2, 3, 4, 5, and 6, we call this as a sample space. But if we are interested on some part of the sample space satisfying a given condition, like for example, we want even numbers only, that contains 2, 4, and 6 only, we call this as an event. Again, let us clarify that an event may have lesser number of elements than the sample space, or it may have exactly the same elements in the sample space. Now let's go to the examples. In these examples, I will show you how to list down the sample space and events in different ways. Example 1. A coin is tossed twice. Find the sample space. One of the ways of listing down the elements of the sample space is using a table. On the first column, that represents the results on the first toss. If you toss a coin, there are only 2 possible outcomes. It's either a head or a tail. On the second toss, however, no matter what is the result on the first toss, there are still 2 possible outcomes. So even if the first toss is a head, on the second toss, there are still 2 possible outcomes. It's a head or a tail. Even if the first toss is a tail, then the second toss could still have either a head or a tail. Combining this, we will then have head-head. This means that the head is the result on the first toss, and the second head is the result on the second toss. We then also have head-tail, tail-head, and tail-tail. Listing down the elements of the sample space will then be head-head or HH, head-tail, tail-head, and tail-tail. The elements then of the sample space are head-head, head-tail, tail-head, and tail-tail. Another way of listing down the elements of the sample space is using a tree diagram. On the first toss, we know that there are 2 possible outcomes. It's either a head or a tail. On the second toss, there are also 2 possible outcomes, a head or a tail, head or tail. Combining them, for the result, we will then have head-head, head-tail, tail-head, and tail-tail. Listing down the sample space, we will have head-head, head-tail, tail-head, and tail-tail. Now let us take note that in this experiment, we can easily identify the number of possible outcomes using the formula ns, or the number of elements in the sample space, is equal to 2 raised to n. The 2 represents the possible outcomes in tossing a coin. There are only 2, head or tail. The n denotes the number of toss. So for example, in this example, the coin is tossed twice. So the n here is 2. There are 2 possible outcomes. That will be the base. And the power is 2. That means the coin is tossed twice or 2 times. Then 2 raised to 2 is equal to 4. There are 4 possible outcomes then. This is the number of elements in the sample space. Let's go to example 2. It's a continuation of example 1. A coin is tossed twice. List down the elements of the following events. Event A is the event of getting exactly 1 head. B, event of getting at least 1 head. C, event of getting exactly 2 tails. D, event of getting at most 1 tail. The first thing to do again is to list down the sample space. The sample space, based on our previous example, is head-head, head-tail, tail-head, and tail-tail. To list down the elements then of each of the event, for event A, event of getting exactly one head, looking at the sample space, which among those elements of the sample space contain exactly one head. These are head-tail and tail-head. So event A contains head-tail, tail-head. No other elements. Event B, the event of getting at least one head. Take note of the phrase at least one. At least one suggests that the minimum number of head that it contains must be one. So it's either one head or two heads. Looking at the sample space, we will then have head-tail containing one head, tail-head containing also one head, and head-head containing two heads. So the elements then of event B are head-tail, tail-head, and head-head. Event C, the event of getting exactly two tails. It is clearly specified that we are only interested of exactly two tails. So exactly two tails in the sample space will only contain tail-tail. Going to event D. Event D is the event of getting at most one tail. Again, when it says at most one tail means that the maximum number of tail is 1. Now, let us clarify this. If the maximum number of tail is 1, then it could be 1 or it could be 0. In this case then, if we will list down the elements of event D, looking at the sample space, this contains no tail at all. That means 0 tail. So head-head is the first element. Head-head contains no tail. Next will be one tail. So we have head-tail, and we also have tail-head. Each contain one tail. But then if we go to tail-tail, that already contains two tails. So it's not part of event D already. That means there are only 3 elements of the event: head-head, head-tail, and tail-head. If you have further questions about this example, you may write them down in the comment section below. Let's go to example 3. In example 3, a coin is tossed thrice. List down the elements of the sample space. Again, we can present this in 2 different ways. The first one is of course using the table. On the first toss, there are 2 possible outcomes. It's either a head or a tail. On the second toss, still there are 2 possible outcomes. It's either a head or a tail, head or tail for each of them. On the third toss, there are still 2 possible outcomes. A head or a tail, a head or a tail, head, tail, head, tail, for each of the outcomes on the second toss. The results then will have head, head, head for the first one, head, head, tail for the second one, head, tail, head for the third, head, tail, tail for the fourth. We have tail, head, tail, 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 head, and tail, tail, tail. If you write down the elements then of the sample space, these will then be head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. We can check the number of elements by using again the formula. The n, or the number of elements of the sample space, is 2 raised to 3. 2 raised to 3, that means 8. There are 8 possible outcomes. This also means that there are 8 elements in the sample space. Counting the elements, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements in the sample space. Another way of representing or listing down the elements of the sample space is using the tree diagram. If you draw the tree diagram, on the first toss, there are two possible outcomes, head or tail. Second toss, for each of the result on the first toss, there are two possible outcomes, head-tail and head-tail. Now, for each of the result on the second toss, there are still two possible outcomes on the third toss. So it's either a head-tail, 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 head-tail. Combining them and writing them as one result, we will then have head, head, head for the first one. We have head, head, tail for the second one. We have head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. Listing down the elements in a sample space, these will then be head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. Again, let us recheck the number of elements. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements in the sample space. Going to example 4. A coin is tossed thrice. List down the elements of the following events. Event A is getting exactly one head. Event B is getting at least one head. And event C getting exactly 2 tails. And event D is the event of getting at most one tail. The first thing to do is again list down the elements of the sample space. We have head, head, head. We have head, head, tail. We have head, tail, head. Head, tail, tail. We have tail, head, head, tail, head, tail, 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 head, tail, tail, tail. Double checking the elements 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements of the sample space. Listing down the elements of each event, event A is the event of getting exactly one head. Looking at the elements of the sample space, head, head, head has 3. Head, tail, tail contains exactly one head. So we have head, tail, tail as the first element of event A. Tail, head, head has 2 heads. Tail, head, tail has exactly one head. So tail, head, tail is the next element. Tail, tail, head also contains one head. Tail, tail, head. Tail, tail, tail contains 3 tails. That doesn't contain any heads. That means there are only 3 elements of event A. Head, tail, 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 head, tail, 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 head. Event B. In event B, the event of getting at least one head. The event of getting at least one head means that the minimum number of heads is 1. So since we have tossed the coin 3 times or thrice, then the minimum number of heads is 1 and the maximum is 3. So if we take a look at the elements of the sample space, we will then have head, head, head containing 3, head, head, tail containing 2, head, tail, head containing 2, head, tail, tail containing 1, tail, head, head containing 2, tail, head, tail containing 1, tail, tail, head containing 1. The only one that is left on the sample space then will be tail, tail, tail because this does not contain any head at all. Event C. Event C contains exactly 2 tails. Looking at the sample space, those elements that contain exactly 2 tails are head, tail, tail. That contains 2 tails at the end. We have tail, head, tail. That contains 2 tails. We also have tail, tail, head. So there are 3 elements of event C. Event D. Event D is the event of getting at most one tail. Again, when I say at most one tail, the maximum number of tail is 1. So it could either be 0 tail or 1 tail. Looking at the elements of the the sample space, head, head, head doesn't contain any tail at all. That means zero tail. We have also head, head, tail. That contains 1. Head, tail, head. We also have tail, head, head. No more. So we have head, 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 tail, tail, head, and tail, head, head. So there are only 4 elements of event D, containing at most 1 tail. Again, if you have questions or clarifications or errors on this example, then please write them down in the comment section below. Going to example 5. Roll a die and take note of the number that appears on top. Find the sample space and list down the elements of the following events. Event A is getting an even number, B getting an odd number, C event of getting a number less than 5, and D is the event of getting a number divisible by 3. For this case, we need to write down first the elements of the sample space. The sample space contains 1, 2, 3, 4, 5, 6, which are all the possible outcomes in rolling a die. If we list down the elements of each of the event A is the event of getting an even number. We could easily identify that by writing down 2, 4, and 6. There are only 3 even numbers from 1 to 6. Event B is the event of getting an odd number. Odd numbers are 1, 3, and 5. There are only 3 elements. Event C is the event of getting a number less than 5. Listing down all of those, we have 1, 2, 3, and 4. Event D is the event of getting a number divisible by 3. So we can list down 3 is the first divisible by 3, and 6 is also divisible by 3. There are only 2 elements of event D. Example 6. Roll a die twice and take note of the number that appears on top. Find the sample space. Again, we can list down the elements of the sample space by using 2 methods. The first one is using a tree diagram. In this case, I would use a vertical tree diagram to maximize the use of the space. In this case, there are 6 elements on the first toss, or 6 outcomes. 1, 2, 3, 4, 5, and 6. This then, on the second toss, in each of outcome on the first toss, there are also 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Listing down then the elements of the sample space, we will then have the elements 1, 1, denoting 1 on the first toss and 1 on the second toss. We also have 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Next, we also have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then we have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. We also have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. We have 5, 1, 5, 2. We have 5, 3. We have 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and the last but not the least is 6, 6. All in all, there are 36 outcomes in this experiment. The other way of listing down the elements of the sample space is using a table. In this way, we could easily organize the elements by pairing the results of the first roll of the die and the second roll. So if this will denote the first roll and this will denote the second roll, then the intersection of this and this means that it's 1, 1. the intersection here will then be 1, 2. This should be 1, 3. This should be 1, 4. This should be 1, 5. 1, 6. We have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. We have 3, 1. We have 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Fast forward. Okay, listing down the elements of the sample space, we will then have those elements listed down together. So that will be the elements of the sample space. Now let's go to example 7. In example 7, a coin is tossed and then a die is rolled. List all the elements of the sample space. Again, we can list them down using a table. First one is the coin is being tossed. There are two possible outcomes. It's either a head or a tail. On the second one, we have the die, which is rolled. So there are 6 possible outcomes. 1, 2, 3, 4, 5, 6. The same goes with the second one. 1, 2, 3, 4, 5, and 6. Combining the results, we'll then have H1, denoting that the head appears on the first toss and 1 appears on the die. And then H2, H3, H4, H5, H6. Tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. The elements then of the sample space contain H1, H2, H3, H4, H5, H6, tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. There are 12 elements then of the sample space. You can double check this by multiplying the number of outcomes of the coin and the number of outcomes of a die. There are 2 possible outcomes on a coin, so that means 2. So the number or elements of the sample space will then be 2 for the first, which is the coin, and 6 for the second from the die. So 2 times 6 will be 12. There are 12 possible outcomes, or there are 12 elements in the sample space. Going to example 8. Using the same sample space, find the elements of the following events. Event of getting an even number. Event of getting a number divisible by 3. Event of getting a prime number. And an event of getting a tail and an odd number. Again, our sample space contains head 1, H2, H3, H4, H5, H6, tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Listing down the elements of each event, the first event is getting an even number. So no matter what is the result on the coin, as long as the result on the die is an even, then it's part of event A. So we then have H2, H4, H6, tail 2, tail 4, tail 6. Event B. Event B is getting a number divisible by 3. So if we then have number divisible by 3, we only know that 3 and 6 are the only numbers divisible by 3 from 1 to 6. So we then have H3, H6, tail 3, and tail 6. Event of getting a prime number. Now be very careful with this. A prime number is a number whose factors are only 1 and itself. In this case, we cannot consider 1 as a prime number. The smallest prime number that we could have is 2. So then, if we will write down the elements of event C, then we can then have H2, H3, H5, and also tail 2, tail 3, tail 5. So only 2, 3, and 5 are the prime numbers from 1 to 6. Event D. Event D is an event of getting a tail and an odd number. So it's clearly specified that the first one must be a tail, and the second one is an odd number. So it could be tail 1, tail 3, and tail 5. So there are only 3 elements then of event D. Let's go to example 9. A die is rolled once. When the number that appears on top is an even number, toss a coin. List down the elements of the sample space. In this, we can use again a table. It says that the number that appears on top is an even number, you must toss a coin. So let's list down the results from the die. So there are 6 possible outcomes. 1, 2, 3, 4, 5, 6. But when the number that appears on top of the die is even, you must toss a coin. It means that if the result is a 2, which is an even number, you must toss a coin. There are 2 possible outcomes. It's either a head or a tail. The same goes with 4. 4 is an even number, so you toss a coin. That means it's head or tail. If it's a 6, which is an even, you toss a coin, head and tail. The results then will be 1, 2H, 2T, 3, 4H, 4T, 5, 6H, 6T. The elements then of the sample space contain 1, 2 head, 2 tail, 3, 4 head, 4 tail, 5, 6 head, 6 tail. Now using these results, we can now find the elements of the following events. Event of getting a head, event of getting a tail, event of getting an even number, and an event of getting a number less than 4. Again, let us list down the elements of the sample space. The elements of the sample space are 1, 2 head, 2 tail, 3, 4 head, 4 tail, 5, 6 head, 6 tail. Listing down the elements of each of the event. Event A is the event of getting a head. If we take a look at the values or the elements of the sample space, those that contains head are 2H, we have 4H, and 6H only. There are only 3 elements. Event of getting a tail. In this, we have 2 tail, 4 tail, and 6 tail. The event C is the event of getting an even number. So getting an even number means that we could have 2 head, 2 tail, then 4 head, 4 tail, then 6 head, 6 tail. Event D is the event of getting a number less than 4. That means it could be 1, 2, or 3. So that means we could have 1, we could have 2H and 2 tail, we could have 3, we only have 4 elements. Again, if you have clarifications or questions, or if you see any error on the calculations that we have shown or on the answers that we have shown, please write them down on the comment section below. For your homework, roll a die twice and take note of the number that appears on top. List the elements of the following events. A. Event of getting exactly one even number. B. Event of getting a sum of 10. C. Event of getting both prime numbers. And D. Event of getting a difference of 2. If you are done with this item, please write your answers in the comment section below. I will then verify your answers. At the same time, I will also upload a video that contains the detailed answers of these items. In the next video, we will discuss basic probability and the different rules in probability. So please stay tuned. Thank you so much for watching this video. If you are interested of watching math tutorial videos or math shorts that are maximum of 60 seconds or 1 minute only, you may look down on the description below for the playlist. Or if you would like to have or to visit my blog at www.ciemathsolutions.blogspot.com, you can find their free downloadable review materials and study resources for IGCSE Math, Pure Math, Statistics, Additional Math, and your exam preparations for ASA or IGCSE Math. Thank you for watching this video. For more videos on math proofs and derivations, math tutorial videos, solve items from international exams, math tricks and puzzles, math resources, and more, please don't forget to like, subscribe, and share. Thank you very much for your continued support to CIE Math Solutions.